Okay, let's talk about simultaneous equations. So what does that mean? So we know simultaneous means happening at the same time, right? So what that means is, let's say you had two different equations. Let's say you had y is equal to 5 plus 3x, and you also had y is equal to 2 minus 4x. You want solutions for x and y, right? You want two numbers, x and y, question mark, question mark, that will solve both of these equations at the same time. So if I put x in for this, I'll get a value for y. And if I put the same value of x in for this, I should get the same value of y. So that's what simultaneous equations do. They give you a pair of solutions that work for both equations, or more than two equations if you do higher order simultaneous equations. But we only focus with two equations right here. So let's do an example. So let's say you bought, let's do a real life example. Let's say you bought three bananas, right? Three bananas. And you bought two oranges. And someone tells you that you have to pay $5 for that. But let's make it $5.20, right? And let's say next time you went to store, you bought two bananas and you bought four oranges. And let's say this time you only paid $3.20. So now someone asks you, okay, how much did you pay for one banana and how much did you pay for one orange? Well, how would you do that? Let's say now you wanted to buy six bananas and four orange, right? Four oranges. Oranges. How much would that cost you? And right now you can't really tell because you don't know how much these are worth individually. You don't know how much one banana is. You don't know how much one orange is. But you know if you bought three bananas and two oranges, you'd pay this much. And if you bought two bananas and four oranges, you'd pay this much. So how would you find out what each banana and what each orange is actually worth? So let's call a banana X and let's call the orange Y. So Y will be orange and X will be banana. I don't want to use bananas and oranges the whole time because it's like a lot of writing. So from now we'll do this. Well, if you bought three bananas, that's like buying three of X. Plus, you also bought two oranges, so that's two of Y. And you paid $5.20, so that's 5.20. And then when you bought two bananas, that's two of X. Plus four oranges, that's four of Y. Well, you paid $3.20. So this is equation 1. This is equation 2. So how would you find x and y on its own? So let's think about it. So you can do it two ways. You can either get rid of x or you can get rid of y. So let's get rid of y. So if you bought three bananas and two oranges, you paid $5.20. That means if you multiply everything by 2, then you would get 6 bananas, because 3 times 2 is 6, plus 2 times 2 is 4. So plus 4 oranges, and then is equal to, you'd have to pay 5.2 times 20, so you end up paying $10.40. Well, and if you bought two bananas and four oranges, you pay $3.20. So you can see 4 and 4 are in both these equations right here. So what can we do? Well, call this equation 3. This 6x plus 4y is equal to $10.40. If you did equation 3 minus equation 2, what would you get? Well, you can take this part right here and subtract from this part right here. And you can take this part, $10.40, and you can subtract from here. So let's try it. So if you did 6x plus 4y minus, and then brackets, 2x plus 4y, I've put it in brackets because it's a different equation, is equal to, well, $10.40 on this side minus 320, and this is also in brackets on this side. Well, what do we get? We get 6x minus 2x, that's 4x, plus 4y minus 4y, that's 0y, and that's what we want. We don't want y anymore. We want to get rid of it. So you're left with 4x is equal to $10.40 minus $3.20. That's, you're left with 7.20. And then, well, you can just find x on its own. You can just divide by 4. So you're left with x is equal to 7.2 divided by 4 is 1.8. So $1.80. But that's what x is. X is a banana, right? So that means each banana is worth $1.80. And now how would we find y? Well, if x is equal to 1.8, you can choose any of these two equations because, remember, the whole point is that the value for x and y is going to work for both these equations. So let's choose equation number 2 because we didn't really use it that much. So I have 2 times x is 1.8 now, plus 4 times y is equal to $3.20. Well, what is, if you rearrange on both sides, you get 2 times 1.8, which is 3.6. And I've realized what I've done here. This is kind of stupid, but you'll see what happens. And then you have 3.6 plus 4y is equal to 320. Well, you have 4y is equal to 3.2 minus 3.6, so that's negative 0.4. And you're left with y is equal to negative 0.1, which doesn't make a lot of sense in our question because we're dealing with oranges and bananas, and you never get, it's like negative 0.1 means you're getting 10 cents for each orange you buy, which I guess it could be a discount deal or something, but that's because I just made these numbers up. That doesn't make a lot of sense. So if you bought 6 bananas and 4 oranges, let's say that was a discount, right? So you would do 6 times, how much is a banana? Is 1.8 plus 4, how much is an orange? Is negative $0.1. See, that's 6 times 1.8 is 10.8, and then minus 0.4 is 10.4. So you end up paying $10.40 for 6 bananas and 4 oranges. And these values of x and y, so you're left with x is equal to 1.8 and y is equal to negative 0.1. These are going to work for both these equations. You can try put them back in the calculator. If you put x is equal to 1.8 and y is equal to negative 0.1 in here, you'd end up getting 5.2. And if you put x is equal to 1.8 over here and y is equal to negative 0.1 here, you end up getting 3.20. So they'd work. And they work because what you're really doing is, this is the graphical representation of it, is 3x plus 2y is equal to 5.2. That's a line, right? Let's say that line looks like this. And 2x plus 4y is equal to negative 3.2. That's another line. Let's say that line looks something like this. I don't know what they actually look like, but let's say that's what it looks like. What you're finding is you're finding this point right here where they both intersect. And then you're reading off the x value here, and you're reading off the y value over here. That's what you're actually doing. And that's why you only have one solution that works for everything. You're basically finding the point of intersection of two lines. And this is how you do it. So let's do an example question and it'll make more sense. To solve the simultaneous equations, you must show all your working and give your answers correct to 2 decimal places. Okay, we have decimal places. So we have 2x plus y is equal to 7, and we have y is equal to 5x squared plus 2x minus 13. Okay, this is a bit more difficult because we have x squared now. It's not just x. So we can't do what we did in the first time. We can't just subtract these two equations because, well, you could actually, but I want to show you a different way of doing it. So let's rearrange this equation, and you're left with y is equal to 7 minus 2x. I haven't done anything. I've just brought the 2x to the other side. Well, think about it like this. If I tell you 6 plus 5 equals 11, and then I tell you 12 minus 1 is also equal to 11, well, that means 6 plus 5 is equal to 12 minus 1, right? Would you agree? Because they both equal 11. Well, you're doing the same thing. You're saying 7 minus 2x is equal to y, and then you're saying 5x squared plus 2x minus 13 is equal to y. So what you're really saying is that 5x squared plus 2x minus 13 is equal to 7 minus 2x. Using this logic right here, because if this is 11 and this is also 11, then they should be equal to each other. And if this is equal to y, and this is also equal to y, then they should also be equal to each other. Well, now you can rearrange. So you have 5x squared plus 4x minus 20 is equal to 0. And you can use the quadratic formula and get the value for x. So you get x is equal to minus 4 plus or minus. If you don't know how to solve this equation, you should watch the video on quadratic equations that explains how to solve these type of equations. So you're left with x is equal to minus 4 plus or minus square root of b squared is 16. Minus 4ac is 4 times 20 is 80 times 5 is 400. 16 plus 400. All divided by 2 times 5 is just 10. So you get x is equal to, well, let's take my calculator out. So you have square root of 416 minus 4 divided by 10. So you have 1.639. So you're left with 1.64 because 2 decimal places. And you have x is equal to minus 4 minus answer divided by 10. Negative 2.4396, which is negative 2.44. Okay, you have two values for x. So how would you find the value of y? Well, you can put it into any of these equations, of course, but why would you want to put it into this equation when you can put it into the simpler equation? So you have y is equal to, well, if you do 1.64 times 2, and then 7 minus that, you get 3.72. 3.72. And then you have y is equal to, and then negative 2 times negative 2.44, and then 7 plus that is 11.88. So 11.88. And now to write the final answers, you have to be careful. So make sure you match the correct answer with the correct number. So when we had x is equal to 1.64, you can't write y is equal to 11.88 for that, because we didn't put that number into the equation. We put 1.64 in and we got 3.72 instead. So you have to write 3.72 with 1.64. And when you put x is equal to negative 2.44, that's negative 2.44, you can't put 3.72 because that's not what we got. We got 11.88. So make sure you match the correct number with the correct you match the correct x number with the correct y value, because what it looks like when you graph it, because remember, all we're doing is finding 2 points of intersection now. So you have y is equal to 5x squared plus 2x minus 13. So let's say that looks something like this. And then you have y is equal to 7 minus 2x. Let's say that looks something like this. That's not what it looks like, but let's say it looks something like that. What you're really doing is you're finding this point right here and this point right here. And for this point, you're reading off this x value and this y value. And for this point right here, you're reading of this x value and this y value. That's why it's important that you match them correctly, because if you did this x value with this y value, that would not make any sense, because that's not where the line intersects the curve. So yeah, that's simultaneous equations, and that's quadratic simultaneous equations. So what we've learned is that this is just a way of solving two or more equations and getting two numbers or more numbers that match and will be applicable to both of these equations at the same time. So in this case, when we got x is equal to 1.8 and y is equal to negative 0.1, they would work for both of these equations and give you the right answers. So yeah, that's the importance of simultaneous equations. And we saw what they did graphically as well. It's where you basically intersect two different equations. So yeah, if you like this video, then like, comment, subscribe, and share, and let me know what else you want to see in the comments.